So we're going to start by looking at the bottom left of the page. We've already done these dilations. All right, sorry, now we have to get back to it. All right. Anyways, what we're going to do to start off with today is we're going to look at the properties of these, and hopefully as we were doing these dilations yesterday, you were noticing a few things about them. And what I'm not talking about is that they either reduced or enlarged. We already know that. But I want you guys to look at these specific ones right here, though we could have looked at any of the dilations you did yesterday. And do you notice any properties that are true for every dilation? So you look at the pre-image, you look at the image. What do you notice in the diagram itself that's true for every dilation? Yeah. They're all the same shape, and actually that there is a property there. Now we say they're the same shape, and that was we talked about that already, but there's a property embedded when you say that. When you say that these two triangles are the same shape, what we're really saying is that all of the angles are the same. So what I'm going to do real quick is if I look at all the angles right here, in this, I'm looking at the bottom right triangle. It might be better if we turn the lights off in the room. It might be easier to see. Someone could turn those off for us. All right, so if we look at the bottom right triangle, and I could do this with any, I just want to clarify, but I think it's easiest to see here maybe, that if I compare the corresponding angles, and I'll do this last one as well, we can see that all of these corresponding angles are the same. So one of our properties is that angle measures do not change. So I'll put right here, angle measures are preserved. And this is a really key idea. And now what I want you guys to focus on, I'm going to try and help guide you to what these properties are. What I want you to focus on, let's look at this triangle right here, problem 2C. Compare the side, just pick one side of your pre-image. I don't care which one, if it's AB, BC, or AC. Pick one side and compare that one side to its image. Corresponding image side. What do you notice about those two sides? All right, so I'm going to pick this side BC, and I'm just going to draw along this real quick, and then I'm going to draw from B prime to C prime, which is a corresponding side. What do you guys notice about these two lines that I just sketched in? There it is. So Katie just said it. They are parallel. All right, so all corresponding sides, when you're done with a dilation, all corresponding sides will be parallel to each other. And this is still true even in a negative dilation. So we're only looking at the positive ones right here, but that's also true. So anyways, I'm going to add a little note here. I'm going to say corresponding sides are parallel. Okay, let's go to the one above this. And I'm not going to try and make you guys discover this one. I'm just going to kind of draw So I'm looking at problem 2a, and I'm going to draw from the center of dilation. I'm going to draw a line going out through the preimage and image points. And what's something that you notice? I mean, the fact that I'm drawing this line, so that is what you're supposed to notice, that if I connect the center of dilation through the preimage to the image, they always line up. So I'm not going to have this line going from G to A and then A prime is somewhere off of that line. They are always going to fall on the same line. Going from G to B, B prime, if I extend that out, B prime is going to be along that line somewhere. And then same thing here, G to C, if I extend that out, C prime is going to be along that line somewhere. So this is an idea called collinearity, all right, which is a fancy way of saying that from the center of dilation, all your points are going to line up. All the corresponding points will line up. Okay. So those are 3 properties, and then we have one more. And so we'll go to the 4th triangle over here to show this one. We've got our preimage and image for problem 2b. And what I want to do is I want to look at the distance here. So hopefully you can see where I'm drawing that. So the distance from E to F is, in this triangle right here, is what? And you've got the same triangle on your paper if you need to look there. What's the distance from E to F? 3 units, yeah. So we're just counting 3 boxes over, and so that's 3 right there. And then if I go to the image, E prime and F prime, what's the distance from E prime to F prime? 6. All right, now this, more than any of the other properties, this is one that we're going to come back to quite a bit. Now keep in mind, what was our scale factor for problem 2b? 2. So all of the sides grew proportionally. So I started at 3, and because my scale factor was 2, I just multiplied that by 2, so I ended up with a side length of 6. So all the sides grow proportionally. They're all multiplied by the scale factor, and that gives you what your image side lengths are going to be. Okay, and we're actually going to come back to that idea in a little bit actually very soon. So of these properties, the reason that I'm telling you about these is they will come back up as we go through similar triangles. Similar triangles are really nothing but dilated triangles. That's why we're starting here with dilations. Now, dilations, as they appear when we graph them, they have these properties that the sides are going to be parallel, the sides are parallel, and they have this collinearity. If I separate the triangles, then it kind of loses those properties. But proportionality and angle measures being preserved, that's true of all similar triangles. All right? So it's these properties that will come back into play. So if you understand it now, then it's just going to make understanding what we do with similar triangles that much easier as we go through. But we also are going to very practically use some of these. So if you're doing a dilation, you can just remember, the corresponding sides are supposed to be parallel. Are my corresponding sides parallel to each other? So you can just quickly double check that. And if you made a mistake and you don't have parallel sides, then you can go from there and figure out where you went wrong. Okay. So we're going to come back to the idea right here, proportionality. Oops, didn't mean to do that. And let's look now at the back side of that page. Let me get over there. All right, and this is what we're looking at now. This is not going to, a lot of this I think will be pretty straightforward. But in order to understand the idea of scale factor, finding a scale factor, there's something we need to keep in mind. And that is there we are, that I'm going to go to a blank screen real quick. The scale factor, well, I'll call it K. Sometimes we use R, but I'll call it K. So the scale factor is just going to be your image side length. And I'm going to give you an example of this. Image side length all over the pre-image side length. And we're going to use this for the backside in order to help us find the scale factor. Okay, so imagine, I'm going to draw a little sketch right here. You can draw this if you want to, or you can just kind of follow along and use it here in a minute. All right, so let's say I dilated this triangle right here, and I have now this triangle right here, and I actually made it too big. It's going to go off the screen a little bit, but that's not a problem. Let's say in this triangle right here, this is A, B, C, and this is A prime, B prime, and then C prime went off the screen. So AB is 4, and A prime, B prime is 16. Okay, so what we want to do is we want to take our image side length, and I want to, the image side length right here that I'm interested in is A prime, B prime. I could have picked another side if I wanted to, but I'll just take A prime, B prime because that's the only one I have numbers for. So for our purposes here, it's going to be the image side length is 16. The pre-image side length is 4. So now, just with those numbers, I can divide, and that gives me a scale factor of 4. All right? Did that make sense? And I'll...
What's the thing on top called?
The image side length. All right, and just to show you kind of how this could change, let's say that I'll erase a little bit real quick, and we'll use this here in a second on that page that I handed out. All right, let's change this up. Now, I'm going to change the lengths too. Now this is our image. In the smaller one is our image, and this is our pre-image. And I'm going to say this is 14, and this one is 4 still. Now it's the pre-image over the image. Okay, or sorry, it's the image over the pre-image, I should say. So the image right here is a smaller triangle. Remember, the image is always your primes. So I'm going to put the image length, which is 4, all over the pre-image, which is 14. And that tells me that I have a scale factor of 2/7. All right. So these are kind of some random examples that I put up on the screen. But if it's making enough sense for right now, we're going to see how we're using that on this backside. All right. So we'll keep in mind the image over the pre-image will tell us our scale factor. So let's look right here at this. So the way that we're going to find our center with all these triangles is we just take a straight edge, and if you don't have a straight edge, you can just use an ID card, anything in your backpack that gives you a straight edge. And we want to line up our corresponding points. So C and C prime, I will make them line up, and I'm going to draw a line coming back in space. Okay? And I'm going to do the same thing with A prime and A. And you can see that right there. Do you see how I'm just lining up A and A prime, B and B prime? And then I'll do the same thing with C and A, B, and C. So I want all three of these. And when I line these up, I end up with these all coming back to just one point. So if I connect A and A prime, draw a line, B and B prime, draw a line, C and C prime, draw a line, it will come back to one specific point, and that point is the center of dilation. So all you have to do for the first part of these problems is just do those connections and then write the coordinate that it ends up at. So when it says the center up here at the top, it wants you to give the x and y coordinate of your center of dilation. So right here in this case, what is center of dilation? Where is it at? Negative 2, 1. And before we worry about finding the actual scale factor, like the number and setting anything up, I just want to ask you guys, in this example, is our triangle getting bigger or is it getting smaller? It's getting bigger. So remember, your image is the primes. That's where it ends. So this one is getting bigger. And so what I want you guys to do is ask yourself that question to begin with. The most common mistake for something like this is to already have an idea of what the scale factor is, but mix up if it's getting bigger or smaller. So instead of a scale factor of 2, you write down a scale factor of 1/2 because you mix up your pre-image and your image. All right? So as far as this goes, my first thought would be to just kind of see if you can figure out what the scale factor is. So in this case, does anyone already know what the scale factor for this one's going to be? It's going to be 2, and we can tell what's happening is that this side length right here,
It's doubling.
yeah, if you go from B to C and then B prime to C prime, it's twice as long. So I'm not trying to make this seem complicated because a lot of this is going to be like, oh, it's 1/2, it's 2, it's 3, it's 1/3, something like that. But it can get complicated. So if we look at the next one, not the next one, but C. We'll look at C real quick. We'll find the center of dilation on this. Actually, I didn't want to look at C either. I wanted to look at, let's go with D. Okay, so with D, I'm going to line up A and A prime, and this one happens to work out where if I line up A and A prime, it also lines up B and B prime. And then C and C prime. All right, so right here, I just lined these up, and I came up with my center of dilation. You guys still good with that?
Yeah.
Okay. That means my center here is going to be at what? 1, -1. And the scale factor, remember, it is your image distance over your pre-image. So this one works out very nicely where you've got this horizontal line. How long is it from A prime to C prime? 3. So my scale factor here, I'll just write it as going to be the image over the pre-image. What is it from A to C? 9. So now I can simplify that down to 1/3. All right, do you guys have any questions on this? Okay, I hope it is easy and you're getting the hang of it. So take a little bit of time and just focus on these types of problems.